So if you need to look at that again, yesterday we talked about chapter 4.1, which is identifying our polynomial functions. That was one of our goals in their degree. Remember, degree is the largest exponent, okay? Goal number 2, we talked about zeros of a polynomial and its multiplicity. So we talked about even multiplicities, that's the exponent. Even multiplicities touch in odd cross. So this is an example of a cross and a touch. Okay. So to remind you, ETOC, I always remember it's odd when somebody's cross-eyed. My son, I showed you that video of my son yesterday. It's a little weird. I posted that. You could watch it again. All right. Now we're analyzing the graph. So basically, we're going to walk our way through. Okay. And we're going to basically do everything that we just did from 4.1, and we're going to do that on 4.2. Okay. So as we take a look, I've got my function. I've got f of x equals x squared plus x plus 3 squared, and then the quantity x minus 1. Okay, the first thing I want us to do is list out our x-intercepts or our zeros, and then determine whether the graph touches or crosses, and that goes back to ETOC, even multiplicities, even exponents touch, and then odd ones cross. Okay, so we've got 3 of them. I got x squared, so x squared, that 0 is 0. Its multiplicity, its exponent, is a 2. Okay, and then we have to identify that number. That 2 is an even number, even touches, so that's a touch. Okay, so I look at the next one. I got x plus 3, quantity squared. Shout it out. What's the 0 and its multiplicity? What do you guys got? What's a 0 in multiplicity? Awesome. So opposite of what you see. So if you see x plus 3, it's negative 3 for the 0, because when you plug it in, negative 3 plus 3 is 0. Awesome. And then the multiplicity is its exponent. Okay. Well, that tells me if it's a touch. So ETOC 2 is even. It's a touch. Okay. I don't know if you can tell I'm using different colors. Let me know if you can't see that pink. Okay. And then here's green. I got x minus 1. Opposite of what you see, so it's positive 1. It's a multiplicity of, if you don't see a number, it's just the 1. And then 1 is odd, OC, ETOC, that's a cross. Okay, so I have 3 zeros here, okay? Remember, zeros are x-intercepts. So now I'm going to go down to my graph, and I'm going to graph those guys, okay? So we had 0 on the x-axis is right here at the origin. Okay. So x-intercept, I like to write out what I've done here. I've done my x-intercepts. I've got 0. I have negative 3. 1, 2, 3. To the left, and then I've got 1. So right now I've done my x-intercepts. I've got 0, I've got negative 3, and I got 1. Yes, sir. Down and to the right.
Yeah, perfect. Thank you.
Yep. Zoom out just a touch here so we can see it all. So I've done the x-intercepts. I've done my 0. Multiplicity of 2 is right there at the origin. I got negative 3 with a multiplicity of 2, so just over 1, 2, 3 boxes. And then I got 1 multiplicity of 1's right there to the right on 1 box. Okay? All right, y-intercepts. What do you guys know about y-intercepts? Y-intercept is when x equals what? 0. So when I plug in 0, 0 squared is 0 times whatever. 3 squared is 9. 0 times 9 times negative 1. 0 times anything is 0. Okay, so my y-intercept, I want to graph that. That's right here on the y-axis. That's at 0, 0 also. So that's done. So right there at the origin is the x-intercept and the y-intercept. Okay. So far, so good. So y-intercept is 0, 0. Now in behavior, guys, okay, in behavior, so I'm going to review what in behavior is. You basically have 4 choices, okay? We look to see what the degree of our guy is, okay? And we want to see if it's even or odd, okay? If it's even, then I have 2 choices. If it's positive, it's going to be a smiley face type, where it's going up in both directions to positive infinity. And then if it's negative, it's going to be a frowny face. So if my leading term, if I was to FOIL this thing out, I'll look to see what I have. If it's even, it's going to be a smiley face or frowny face. Versus if I have y equals x to an odd power for the leading term, then I would have an S curve. If it's a positive, it'd be going up to the right, down to the left. And if it's negative, then it's flipped. It's going down to the right and up to the left. So I really have 4 choices, okay? Now yesterday we talked about if I want the degree of something is the sum of your multiplicities. Okay, so if I want the degree, take your multiplicities. I have 2, 2, and 1. Add them together as sum. So I get a degree of 5. So if I was to FOIL this thing out up here, right, I would get an x squared there, I would get an x, so x squared times x is x cubed, and then times an x squared, that's x to the 5th. And now it's odd, so it's one of these. If it's positive, it goes to the right, up to the right, and then down to the left. All right, any questions with that? So that was in behavior, what we talked about yesterday. This is our in behavior. This is what it's going to look like at the ends of my graph, okay? Now, mins and maxes, this is where I grab my calculator and I graph and see what I get, okay? And mins and maxes are also known as turning points. So a min and max is a turning point. That's where it goes from increasing to decreasing or decreasing to increasing, okay? At the max for turning points is equal to your degree minus 1. So for our example, 5 is our degree minus 1. At max, I will see 4 mins or maxes, 4 turning points. Okay, I don't really care about that. That's just technically like a truth that we need to know. Like for example, if I have a quadratic like y equals x squared, there's 1 minimum or maximum, right? And it's just your degree, 2 minus 1. There's a max of 1 for that one, okay? So in this one, we have a max of 4 mins or maxes. So I could find 4 mins or maxes. I could find 3, 2, or 1. I don't know. We're just going to have to graph it and see what we get, okay? So this is where we grab our fancy calculator, okay? Now, if I have my plots on, because we just did scatter plots, if I have that highlighted, I'm going to go up in plot 1 and press enter, and that turns it off, okay? So then now I'm going to go up to our function. I'm going to type it in. So I've got x squared. Parentheses are above the 8 and the 9. So parentheses x plus 3, close it, squared. And then parentheses x minus. The minus above the addition sign is what we're using. So the big minus sign above the addition. So minus 1, close it. You don't need it raised to the first power because it's assumed it's raised to the first if you don't write it. All right, so I've got x squared, parentheses x plus 3, quantity squared, and then quantity of x minus 1. All right? All right, so I was starting zoom 6. Okay? And now understand what we should be looking at. Okay? We should be looking at a continuous graph. So this is my graph that you should get in zoom 6.
This is where I stop and just verify that everybody is in the same spot. So this is a time where you guys give me a thumb on where we're at. Can I get a thumb? And please, oh my gosh, please tell me you're doing this, right? If you're sitting here watching Netflix, oh my gosh. Oh man, good luck on the test on this stuff, man. Holy moly. All right, is anybody having issues with this graph? Anybody not able to get this graph? Okay. Now, when you're doing polynomial functions, you have to understand that you're like a roller coaster designer, okay? If you're looking at this roller coaster, do you want to ride it? Is this a roller coaster you would want to ride? And I would be shaking my head, no way, okay? Because on a roller coaster, there should be track everywhere, right? And I see down here, I'm missing some track. So if you were on a roller coaster ride, I'd be going up, and then all of a sudden I'd go down, and then I'd go, ah! And then there's no track, and then I would die, right? So I want to see all of the track, and I'm missing track right here. So that means I need to make this window bigger. Okay, now before we did a lot of zooms, I don't want to do that for this lesson. I'm going to go to window. Okay, and I need to go to my Y min and Y max and make it bigger. Okay, usually I count by 10, so I'm going to try negative 20 and 20. Okay, never need to change your x's. Your x's should be fine. Negative 10 and 10 is fine. It's the y's that you need to change. So negative 20 and 20, I press graph, and now I should see my entire graph. Okay? When you do a polynomial function, the domain of this thing should be negative infinity to infinity, which means there's no breaks, gaps, or holes in my graph. Again, if you're a roller coaster designer, I should see the entire thing all the way. Okay? And I can tell, like, okay, this looks pretty good. Anybody not getting this graph? So again, just to walk you through what I just did, I did negative 20, 20 for my Y min and Y max. If you guys get those mixed up, you're going to get a window range error. That just means you have your mins and maxes mixed up. And now I want to find my mins and maxes. All right, let's talk about these maxes here. Okay, so that's the first thing we want to do. There's a maximum. There's a maximum. Okay, what do you notice about these two maxes? Where are they located? That's my question. Where are these two maxes located?
On the x-intercept.
Yeah, these are your x-intercepts, specifically at negative 3 and 0. Well, any time that you have a touch, that is going to be a min or max. Okay, in this case, those are both your maxes. Okay, so anytime you have a touch, that's a min or max. In this case, a max. All right? So if you want to find those with your calculator, you can, but I already know what they are. I know they're 0, 0, and I know they're negative 3, 0. But if you didn't know that, well, we know how to find mins and max in the calc. Second trace, maximum. I'm going to find this far one on the left. So I'm going to go on the left side is where it's decreased or increasing. Right side is where it's increasing. So I'm going to move over to the left of that point. Okay, I'm going to press enter on left bound. Right bound gets to the right where it's decreasing. Press enter. Yes, press enter. And there we go. I got negative 2.99999. Again, that's negative 3. And remember, anytime you get an E, that's scientific notation to move your decimal place over. In this case, I have 11 to the left. That would be 0.000000000000018. Okay, you guys probably got something different, but that's 0. Okay, you do not need to do the maximum here on your calculator because we already have it. It's a touch. Anytime it's a touch, there we go. So you could go through and find that other one there, but we know already that's a touch. That's 0, 0. So you can find it, but I don't need to because we already did it. Any questions on why I have 0, 0, negative 3 as my maximums? Okay. Now, one thing I like to do is when I'm graphing my maxes, I know here at -3 is a maximum, right? So that means I've got a little bit of a hill here. So I put a little hill there. And then I know this here at 0, 0 is a maximum, so I'm going to put a little hill there. Just so I know, oh yeah, that's a touch, that's a maximum. Okay. All right, next I want to do my mins here. Okay, so my mins, I got one right there. So let's find this guy. So this is the left of that, that's the right. So I'm going to go second trace minimum. I'm in a min. Left bound, get to the left, press enter. Right bound, go to the right, press enter. Yes, press enter. And it jumps to the minimum. Don't write anything until you see the word minimum. In this case, I got -1.7. It says round to 2 decimal places, so that's 0.4, so that's 0. Comma, -13.187, so that's 1.9. Okay. So I'm going to go over 1 almost to 2. And remember we counted to 20 and -20, so remember we're going to count by 2's here. I like to put the scale on the outside, so I got 20, -20, so I'm going to count over 1, 2-ish, almost to 2, but not quite to -2. And I'm going to count by 2's. 2, 4, 6, 8, 10, 12, 13-ish would be right about in the middle. And I'm going to put a little valley there. Okay, so that's a minimum, so I'm going to put my little valley right there. This is over 1, almost to 2, and down. 2, 4, 6, 8, all the way down to -13.18. Any questions on that one, y'all? All right, so I got one more to do. I got to find this guy right there. That's the left, that's the right. So I'm going to go second trace, minimum. Left bound, get around 0, 0 where it's going down, press enter. Right bound, get to the right of that where it's increasing, press enter. Yes, press enter, and it jumps to the bottom. If you're not getting these, let me know. I've got 0.704, which is 0.70, comma, -2.01. Remember, don't write anything until you see the word minimum. Okay, so I'm going to go over 1-ish, not quite to 1, and then down 2. Remember, that's just down 1 box. Make my little valley. Okay. So I've got my maxes, I got my mins. Okay, so I got my y-intercept, I got my max, check. I got my min, check. I have all of those things graphed. So now it's just follow your graph. It starts way down here. My in behavior says it starts down on the left. It goes up. It maximizes. It touches that x-axis, comes back down. Minimizes right here at -13. Goes back up. It maximizes and touches right there. Comes back down. Goes back up after the minimum. And just keeps crossing over that x-axis and keeps going. Arrows on the ends of your graphs because it keeps on going in that direction. Okay. Again, this is just a rough sketch. We're analyzing what this graph is. To analyze, I need the x-intercepts, the y-intercepts, the mins and maxes.
Gotcha.
Yes.
For like interval notation, we just do like negative infinity.
Awesome question. So domain now, for all polynomial functions is always all reals, -infinity to infinity. And then your range, how low does it go? Does it go down low, down to the flow? For sure. How high does it go? Does it go up high all the way to the sky? For sure. It just keeps on going up and up and up. So domain in this case is -infinity to infinity, and then your range is -infinity to infinity. Okay, great question, Leo. All right, any questions with this one? I got my x-intercepts, my y-intercepts, my mins and maxes done. And that's how you analyze a polynomial function graph. Okay, so good stuff, getting you guys ready for calculus. We start analyzing more and more graphs. All right, let's move on to the last one. Any questions on this one before I move on, y'all? Again, I see a lot of people with no cameras on. I hope you're doing this. Please tell me you got a calculator out and you're writing this stuff down.
Mr. Gotsch,
What's up?
like for on the left and right around like the x-intercept, when you put 10, like, do we only change the y-intercept to 20?
Yes.
-20?
That's the only ones I changed. Yes. I never change these. I always count left and right ones because that's usually all you need. It's the y's that will be changing.
Okay, thank you.
Yep. Good question. All right, ladies and gentlemen, so this is what we call factored form, right? This has been factored. It could be FOILed out. Okay, so this is what to do if it's in factored form. Okay. And when I look at the last example for today, before we get out of here, okay, this has been factored. This has already been FOILed out. Okay, this is what's called general form. Okay. When I'm doing x and y intercepts, okay, specifically x intercepts, when I'm trying to find my zeros, I can't just look at this thing and identify what the zeros are. So the biggest mistake is when somebody sees general form, they just say, oh, the zeros are 1, 4, -16, and -64. And that is not the case at all. Okay? So if you want to find the x-intercepts, you have two choices. Okay? You could try factoring this thing, okay, which I don't want to do factoring, okay, but you could. Or you got to use your calculator. So if I'm going to do x-intercepts in general form, I'm going to use my Calc. Okay, and to do that, I'm going to do one of two things. I'm going to use my y2 as 0. And I'm going to find the intersection, or I'm going to find a min or max if it's a touch. Okay, so first thing I'm going to do is I'm going to throw this in my calculator so I can find my x-intercepts, my zeros. Okay, so I'm going to go to y equals. Clear that out. Make sure your plots are off. Again, I hope you're checking this out. This is different than the last one. So I've got x cubed plus 4x squared minus, use the minus sign above the addition sign between terms. So that's minus 16x minus 64. Make sure you're using the minus sign above the addition. Okay? So x cubed plus 4x squared minus 16x minus 64. And then go to y2 and have that as 0. Okay? And I always start in zoom 6. And again, we're looking for a nice roller coaster ride. There's no way I'm riding this roller coaster. I do not see all the track. There's no way I'm doing that. Okay? Now, how far do we make this? Okay? A little hint is if I plug in 0 for my y-intercept, right? I use the cover-up method and cover up all the x's. I've got to get down past -64 for the y-intercept. Right? So my y-intercept is 0, comma, -64. So when I'm doing my window, I'm going to go past that constant. So I'm going to go all the way to -100 for my y-min and y-max. So I'm going to do -100, and then my y-max is +100. Okay, usually that's as far as you have to go. Usually the cap is right around -100, 100. So my choices usually are either -20, 20, -50, 50, or -100, 100. Okay? So I got my x's Gavin stay, my y's are the ones I switch. Never change the x's, you never have to. At least not the ones I've given you. This is a roller coaster ride that I want to ride. Right? I see the entire graph from -10 to 10. Looks fine. Okay? What I can see is I got two intercepts. I got one right here, and I got one right here. Okay? This is a touch, and this one is a cross. Okay? The cross is pretty easy to see. It literally goes from one side of the x-axis to the other. You know, I'm in quadrant 4 here, and then it goes all the way up to quadrant 1. That's clearly a cross, and that's the one that you can find using the intersection tool. So I'm going to go second trace, intersect. number 5. First curve enter, second curve enter, guess. I'm going to move it over to this intersection and press enter. And it jumps to 4, 0. Okay? So one of my zeros is 4. I don't know the multiplicity. Visually, I can see that it is a cross. Okay? So I definitely know this is a cross multiplicity. So far, so good? Now, if I try to do the same thing, second trace, intersect, first curve enter, second curve enter, guess, if I try to find this one way over here, even if I move my cursor right next to it and press enter, it, for whatever reason, will not find that intersection. It finds this one. Okay? So to find this touch, it's not only a touch, it's also a maximum. So we know how to find maxes on our calc, so let's go ahead and find that maximum. So second trace maximum, get rid of all this writing here, so second trace max. Okay, so it says left bound, right bound, guess, so I'm going to get to the left of that maximum, where it touches the x-axis, where I think it does. Press enter. Right bound, get to the right, press enter. Guess, press enter, and I got negative 4, comma 0. Okay, you might have got negative 3.99999, again round. So that's negative 4, and that is a touch. Okay, it is also a max, so that's how we found that one on the calc. Okay, so maximum, I got negative 4, 0. All right, let's put those on our graph. So my scale always is 10 to negative 10 for my x's. And then my range, in this case, my y's, I went to 100 and negative 100. And right now, for my x intercepts, I've got 4. 1, 2, 3, 4. And I got negative 4. 1, 2, 3, 4, negative. So my x-intercepts are graphed. Any questions so far, y'all? Give me a thumb on where we're at. Are we getting this graph? Give me a thumb. Pat your head if you're listening. Tap, 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 tap. All right. Can't compete with Netflix. I see some of you guys got the screens going with the flashing in the background. Hope you're paying attention. I cannot compete with the Mandalorian. It's too good. All right. Y-intercept. Y-intercept, again, we already did that by hand. I usually just use the cover-up method. Okay, get negative 64. Or you can go second trace value, x equals 0, enter, and you get negative 64 that way. So you got 2 options. Okay, so 0, negative 64 is that guy. So I'm going to go ahead and graph that. Remember, I'm counting by tens up and down, so go down 10, 20, 30, 40, 50, 60, negative 64 is in between the 6 and 7 box. So y-intercept, check. Alright, in behavior. This one's already factored out. This is already in general form, so my in behavior is going to look like this guy. Okay, so my in behavior is going to look like this power function, x cubed. If it's odd, it's an S curve, and it's positive, so it's going up right, and down to left. And that's what I see visually. At the ends of my graphs, it's going up to the right, and down to the left. That's what I see. Perfect. Minimum. We got the maximum already is negative 4, 0, so negative 4, 0 is going to look like this. I got a little hump there for my maximum. And now my minimum, I want to find this guy right here. That's my min. So I'm going to go second trace, minimum, number 3. Left and right. Left bound, press enter. Right bound, get to the right, press center. Yes, press center. And it jumps to the minimum. In this case, I got 1.333, comma, negative 75.85. graph that. I've graphed the max already. That's done. Now I gotta graph the min. So I'm gonna go on over 1-ish. Not quite to 2, closer to 1 than 2. And then down 10, 20, 30, 40, 50, 60, 75-ish. So in between the 7th and 8th box. So I'm counting by tens. It's a minimum, so I'm going to put a little valley right there. Now my graph here should look exactly as the graph on my calculator. So I follow the graph. It starts way down here for the end behavior. It starts way down here. It comes up. It maximizes. It touches. It comes back down. It crosses the y-axis or the y-intercept. It comes down and minimizes. And it comes back up and crosses the x-axis right there at 4. It goes on forever and ever. Okay. I graph my mins. I graph my maxes. I have a continuous graph. No breaks, no gaps, no holes. Okay. And then domain. Negative infinity to infinity, and then your range starts low, goes all the way to the top. Okay? Now, when we do this by hand, the most common mistakes I see is when people graph this thing by hand, they will zoom 6, and then I will get graphs that look like this. I will get graphs that look like this, and then I get a graph that looks like that. Okay? This, ladies and gentlemen, is mean you're not paying attention. This is not what I want. Okay? That's bad. You need to change your window. Okay? Your Y min, Y max needs to be bigger. That means you just haven't practiced. You're not doing what you're supposed to be doing. You're not doing your homework. Okay? So make your window, make your Y min and Y max bigger. I don't want to see that. That's terrible. Okay? That means you have no idea what a polynomial function should look like. It should be continuous. All right, ladies and gentlemen, that's all I have for today. Do we have any questions on analyzing?